So, good evening, good morning, good afternoon, everyone. This is Group 44. This is Group 44 of machine learning. So, our project is basically that is database risk prediction and extreme label scarcity based on semi-supervised and unsupervised learning. So, let me share my slide a bit. So basically, our group consists of Sandra, me, Oscar, and then Richard. So background shall look at basically introduction, shall look at problem statement, research questions and objectives. We shall look at research methodology, data set description, until way through, that's practical recommendation, feature work and acknowledgements. So basically, we want to have a background of database, what it is. So we see it affects over 537 adults globally, with a projection of that by 2045 to exceed 700 million. And in this case, we see that traditional screening relies on biochemical tests such as HbA1c and fast glucose, blood glucose, which is often accessible in low resource environments or regions. So, what's our problem statement in this case? So we see in low resource regions, many individuals with diabetes remain undiagnosed due to limited access to clinical testing. And we now resort to that symptom-based screening, which could enable early detection, but in this case, what do we need? We need predictive models that must be robust to the reality that most patient records lack confirmed labels. So, and then we go ahead to see what are research questions and what are research objectives. So one, we want to determine whether unsupervised learning can help us identify subgroups linked to diabetes. Then two, we want to also determine whether semi-supervised learning outperform supervised baseline when only a fraction of labels are available. Then you also want to see how effective is PU learning detecting hidden positives when only positive cases are known. So we also want to see which learning paradigm is optimal under different label availability scenarios. Then our objectives basically, one, we want to perform exploratory data analysis. We want to implement and evaluate these supervised learning algorithms. We also want to evaluate we also want to compare all the approaches and derive practical recommendations. So those are basically our research questions and objectives. Then when you come to our research methodology, we follow that is a 6-step approach, where we began with the data loading and way until through, that is interpretation. But in between we go through data pre-processing, which involves cleaning the data to remove noise and anomalies. Then explorative data analysis, where we do a bit of visualizations to help us understand the distribution and the nature of the data we're dealing with. Then we went ahead to do modeling, in this case where we use the various algorithms. Then later on we did evaluation to see which one performed best than the other and why. Then at last we did interpretation. So when we look at the data set we're having, our data set consists of, that's 520 because it was a .csv file. It had, that is 17 features, of which we had gender, age, and then 15 other symptoms rather. So the classes we had 60% positive, then 40% negative. So it's fortunate enough that we do not have any missing value. So the protocol split we use as SPU aware stratified. Now let's look at the uniformity analysis. So in this case, we look at how a specific feature contributes to or relates with the diabetes. So when you look at age, we looked at quite a number of features. In this case, let me point out age. So that the distribution of age with diabetes, it is almost follows a normal distribution or a bell-shaped distribution. Some other cases, it can be the distribution can be left skewed or can be right skewed. So the check distribution helps you to make an informed decision on what to do next on the data set. Then when you look at the bivariate analysis, so here we look at how two features all contribute to contribute to diabetes. So here we have a few visualizations to see the distribution with diabetes. Now we also went ahead to do a pair plot of topmost 5 predictive features, and there you can see the visualizations. Then okay, still here again with when you look at age, so you see that age almost gives us a bell-shaped distribution or a normal distribution with the diabetes. Now my other colleague Richard will take over from here. That's from supervised learning methods.
Hello everyone once again. This is Richard. I'm going to take through unsupervised learning method, of which we were able to implement in this analysis, where we implemented some algorithm like k-mean clustering, where k is selected via elbow method and as in all scores, where we also applied the Gaussian mixer. That is in the modeling, that is where the components selected via BIC, then probabilistic soft clustering were carried out, then the BScan values we were able to obtain them, like the mean sample and also the density based clustering that we were also able to carry out as one of the algorithm in this learning method. Then we had some evaluation metrics in within the algorithm. Then coming to supervised learning, that is now where we were able to combine the label and unlabeled data, so that we can apply some algorithm like label propagation, label spreading. So these processes, we analyzed them and we were able to obtain the corresponding values in the analysis. Then coming to positive unlabeled learning method, here we were just dealing with positive unlabeled data, so that we can literally detect the hidden positive values when all the positive levels were known, like setting up certain fixed 50 level positive, where maybe like 50% of all the positive were able to give us some prediction or some other metrics giving the key insight of the analysis. Then in the method 1 we had two-step that is now PO learning. We trained CLASPER basing on the label positive versus random and level. Basically we had discussed this in the previous presentation, and we shall not waste time on each and every process. Then under evaluation metrics and baseline rather, we had some other question like why is symmetric accuracy is misleading. We find like the model discovering hidden database get penalized for false positive. So we really need a precise recall focus. So those were some of the metric evaluation that we were able to evaluate. Then under result unsupervised learning, we perform clustering performance, where we realized like k-means was giving us the score of 0.28, but amidst all this performance we realized like the DB scan was able to perform better with a score of 0.01. So meaning the density we're evaluating again as the true clusters and density. So under unsupervised learning, we had performed also, that is k-clustering profile, where we had some other insight where we can interpret in a way that unsupervised learning reveal the clinical meaning that subgroup without any labels. That is now where a other I is equal to 0.42. So here we also have some other performance metrics that we were able to see the key insight with their corresponding accuracy. That is where in the label propagation learning this method was able to give us accuracy of 0.88. Then the F1 score was 0.89. Yeah, some small difference in between, meaning the accuracy was quite good. Then label spreading was literally performing well with small accuracy in F1 score. Then also supervised learning 20% only, we had 0.81. Then that was key finding within semi-supervised learning. Then this is a result of PU learning, where we were able to obtain the positive level data values with the associated accuracy, where we can see like two-step PU was able to give us 0.89 and the rest. And a comparative analysis, I'm not going to waste time there because we had in the previous presentation. Then deployment and edge execution, this was a crucial part that was left, and I will now handle where we were able to deploy the models that that we had trained. We selected the best perform model, I mean it's the rest of the models, and were also able to make it deployed on Hugging Face. So the system works by on the user side, that is now the interface, where users enter input, that is now symptom or the medical demographics such as age, gender, the MBI. Then the system now, that is now under the model processing, that is now where the AI models analyze this input data and give the risk probability and associated recommendation for each and every prediction or the input data which is taken in by the model. Then calculate the risk score and provide advice and display. The final stage now is where it displays associated result of the input which was taken. Then the key features associated with this system, it handles data encryption, and users data within the system is actually encrypted. That is now like in other ways the interface is assured in both technical side and the user side. Then limitation and ethnic, we had the dataset scope where it was just covering a narrow scope. Then symptom encoding, we realized like we were just encoding as a binary, that is yes or no. So we opt to cut across some other symptom. Then practical recommendation that we would recommend, like we consider working on only positive level, that is for accuracy. Then unsupervised clustering, that is where we are exploring only the unlabeled data. Then where all labeled data is available, that is we recommend supervised learning. Then the future work, we actually look at now expanding the data set to cover all the key aspect of all the key area of concern. Then calibrating the model, developing probability calibration layers to provide reliable risk confidence scores. Then the lightweight deployment, like the one we have done so far, we hope to scale to more lightweight one. Then fairness and biasness audits. Under references, our project or analysis was referring to these books, that is now database prediction using machine learning and the rest. Acknowledgement, the acknowledgement we extend to our team, that is now the group members who are able to conduct this research, that is Babila Sandra, Oscar Pio, and Richard Ogwal, and also to the university affiliation, that is our lecturers who are able to put their initiative to ensure like the entire process is well, and also guide us in whatever step that we were able to move through. So far the presentation this marks the end of our presentation, and we are actually grateful.